This is section 5.1, part 1, operations with polynomial. Vocabulary in this section is that we're going to talk about simplify, negative exponents, monomial, polynomial, degree of a polynomial, and properties of exponents. Our objective in this part is to multiply, divide, and simplify monomials and expressions. Okay, so what does that mean? Well, let's go right into part 1. So if you turn your book to page 303, we're going to first identify what does simplify mean? Well, to simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. All right? Then our next vocabulary is negative exponents. They are a way of expressing the multiplicative inverse of a number. And the next thing we're going to do is we're going to talk about what is a monomial. So let's recall. A monomial is a number, a variable, or an expression that is the product of one or more variables with non-negative integer exponents. So we said to simplify, we must have expressions that contain powers with no parentheses or negative exponents. So this is simplify. Negative exponent is just another way we're going to learn to write 1 over x squared. It's multiplicative inverse of a number or a variable. And then we said a monomial is a product, so this is a monomial, this is a monomial, this is a monomial. It's a product, so this is implied times 1 or times x to the 0 power. So these are all examples of monomials. So now that we've gotten the definition, let's look at the summary chart of the properties of exponents. And you must learn all these. The power, product of powers. If I have x to the m times x to the n, we simply add the exponents. All right, so if I have x squared times x cubed, we get x to the 2 plus 3, or 5. Now, quotient. Product of exponents. Well, if I have x to the m divided by, his quotient means answer to division problem. It says x to the m divided by x to the n. Then we simply take x to the m minus n. Now remember, x is called the base, m and n are the powers. And order matters in division, so we have to, order matters in subtraction, we have to do this in the correct order. Can't do n minus m, it's m minus n. So, x to the 5th divided by x squared is simply x to the 5 minus 2, or x cubed. Now the negative exponents. So I have negative x to the negative a. We can rewrite this and say 1 over x to the a. And 1 over x to the negative a is equal to x to the a. And this is a, not 9. And x cannot equal 0. All right? So example, so 3 to the negative 5th is equal to 1 over 3 to the 5th. Likewise, 1 over b to the negative 7 is equal to b to the 7th power. This is a negative exponent, or definition. Power rules when you have an exponent raised to an exponent. It's, oopsie. So it simply says x to the m raised to the n power. We simply take and multiply the exponents. So if I have x squared raised to the 3rd power, it's x to the 2 times 3, or x to the 6. All right. Now we can take this product and power of a quotient and expand it. So if x to the y, as long as I have one term and it's a product of two things, then we can simply say this equals x to the a times y to the a power. So if I have 2k raised to the 4th, it's 2 to the 4th, k to the 4th, or simply 16k. I can do the same thing for a quotient. So if I have x over y all raised to the a, I can say x to the a divided by y to the a. And y cannot equal 0. All right. I can also say x to the over y to the negative a is equal to y over x raised to the a. I simply use the definition, change this to positive and change this to multiplicative reciprocal. Now I can rewrite this to say y to the a over x to the a. And x cannot equal to 0 and y cannot equal to 0. Alright, so let's look at examples of those two. So if I have x over y square, it's simply x squared over y squared. If I have a over b to the negative fifth, I simply have b over a raised to the fifth. Then I can say b to the fifth over a to the fifth. And then the last property is the zero property. So if I have any base raised to the 0, it's equal positive 1. All right, and x cannot equal 0. So if I have 7 to the 0, I simply get 1. Now, we said, all right, so in order to simplify monomial, we have to make sure the following things are done. So look at the key concepts on page 304. A monomial expression is simplified formed in a simplified form when there are no powers of powers, meaning x to the m raised to the n. Each base appears exactly once. I don't have x squared times x. All fractions are in simplest form, and there are no negative exponents. So let's look at example 1. It says 2a to the negative 2, parentheses multiplication, 3a cubed b squared times c to the negative 2. It doesn't matter how we do it. It's like a puzzle as long as we do the correct, use the correct properties. So here they're going to change this to say 2 times 1 over a squared. And then we're going to leave this at 3a cubed b squared, there's no negatives, times 1 over c squared. So I got rid of the next negative exponents. Now this simply becomes 2 times 1 times 3 times a cubed times b squared times 1 all over a squared c squared. And I just simply used fraction rules. Now, you can do 2 times 1 times 3 times 1 times a times a times a times b times b. I just used commutative property, a times c times c, and I use definition. This a and this a cancels out. This a and this cancels out. This becomes 2 times 1 is 2, times 3 is 6, times 3 is 18, times b squared, all over c squared. And I somehow added an extra 3, because that's just 3, not 3 cubed, so this is 6, not 18. So you have 6b squared over c squared. Let's look at example B. It's q squared r squared over q to the 7th r to the cube. So the first thing I'm going to do is I'm going to simplify. I'm going to use the quotient property. So I have the same bases here, so I have q 2 minus 7 times r to the 2 minus 3. Oh, sorry, it's 4 minus 3. This is a 4. 4 minus 3. And then I get q to the negative 5 times r to the first power. And I can't have any negative exponents, so I use definition. This is 1 over q to the 5th times r to the 1 over 1 using fraction rules. Then I get r over q to the 5th. It's simplified, no negative exponents, and base appearing only once. Okay, let's look at the next one. So I have a negative 2a to the 4th raised to the 3rd power over b squared. This is all in one parentheses. So the first thing I'm going to do is I'm going to separate this 2a to the 4th raised to the cubed over b squared raised to the cube. Then I'm going to write this negative 2 cubed times a to the 4 raised to the cubed over, using the power rule, 2 times 3 is b to the 6. So then this is implied 1. So it becomes negative 2 times negative 2 times negative 2, or simply negative 8. And then 3 times 4 using the power is a to the 12 over b to the 6. So I use power rule, I use I use quotient, I use the quotient of products. So as long as I use the correct definition, it does not matter. All right, let's look at page 305, operations with polynomial. So first of all, what is a polynomial? A polynomial is the sum of one or more monomials. Basically, that's it. We already talked about what the definition of a monomial is. It's a variable or expression that is the product of one or more variables with non-negative integer exponents, or in other words, exponents that are whole numbers. All right? So how do we find the degree of a polynomial? First of all, the degree of a polynomial is the degree of the monomial with the greatest degree. So we said we have one, it's a sum of one or more monomials. You find the degree of each monomial, and the one with the highest degree is the degree of the entire polynomial. So let's look at example 2a. We've got 1/4 x to the 4th y cubed minus 8x to the 5th. First of all, it says determine if this is a polynomial. Well, polynomial consists of the sum, we can change this plus negative, right, of one or more monomial. Is this a monomial? Well, I have the product of a number times a variable with an exponent, and the exponents are whole numbers, so this is a monomial. And then is this term a monomial? Yes, the product of a number and a variable with a whole number exponents. Yes. So how do you find the degree of this entire polynomial? Well, let's take the degree of each term. A constant always has a degree of 0. Variables have a degree of their exponent. Okay, know the difference, because this 1/4 has an exponent of 1, but that's not the degree. Any constant, which is a number, has a degree of 0. So you take the degree of each variable or number, well, number is going to be 0, so each variable, you add them together. So this is 4 plus 3, so this term has a degree of 7. This term has a degree of 0 plus 5, which is 5. So the degree of the entire polynomial is 7 because that's the highest degree. All right, let's look at b. It's the square root of x plus 4. Well, is this a polynomial? We'll look at term 1, 2, and 3. If we've got 3 terms, yes, monomial, yes, monomial. Nope, this is not a monomial because technically this is written x to the 1/2. And we said a monomial must have a exponent or power of a whole number. 1/2 is not a whole number, so therefore this is not a polynomial. All right, let's look at this next one. X to the negative 3 plus 2x to the negative 2 plus 6. I've got 1, 2, 3 terms. Is this a polynomial? Well, let's look at each term. Whoops, this has a power of a negative 3, which is not a whole number. Therefore, this whole expression is not a polynomial. This one also has a negative, because remember, this can be written as x cubed. You can't have variables in the denominator. That's why the exponent of the variable cannot be negative, because then it would put in the denominator, it's no longer a polynomial. So that's it. It's determining the degree of a polynomial, determining if it's a polynomial or not. And if it is, determine the degree. You find the highest degree. So let's look at one more example. X to the 5th, y plus 9x4 y cubed minus 2xy. Now remember, this is the coefficient, not the power. It can be a fraction. It can be negative. What we said cannot be negative is the exponent. All right, so I've got 1, 2, 3 terms. Is this a polynomial? Well, is this term a monomial? The product of 2 variables, and they have whole numbers as their exponents, so this has a degree of 6, this term. This one, yes, degree of 0 plus 4 plus 3, so this has degree of 7. It is monomial. Is this a monomial? Yes. Has a degree of 2, therefore this every term is a monomial, therefore this is a polynomial. And the degree of the entire polynomial is 7 because it's the highest degree. All right? We will see you in class.